Hola, estamos esperando a Arun. Disculpen los inconvenientes que se han presentado. Estamos con un poco de problemas ahí con la conectividad, el firewall y todo, y ya acabo de enviarle la invitación. Ojalá que él pueda ingresar rápidamente. Estamos esperando acá con Edu. Edu, ¿tú me escuchas? Ah, ya. Hi, Arun. We are here with the Peru Youth. I'm sorry for for the delay. Are you ready? You listen to me? You listen to me? Uh, Arun, I don't listen to you. Hi, hi. No, no, Arun, no listen to you. No, not yet. Do you listen to me? Edu, are you here? Okay. Okay, no problem. Edu, ¿tú me escuchas? Arun no me escucha todavía. Ya, ok. Entonces es el navegador de él, ¿no? Disculpen que estamos en la... Y yo estoy con... Ok. Arun?
Can you hear me now?
Yeah.
Oh, good.
Perfect.
Good. Okay, that's great. All right, so let me put my headset back on. Let's try that. Can you hear me clearly now?
Perfect.
Okay, awesome. Okay, so I have my slides ready. So should we just, how many people are there?
We have 30 people, 30 persons.
Oh, okay. Okay, cool. So how do you want to start then?
Now, now, please.
Oh, okay. And where are the people? Can I see the people here, or are they remote, or?
Both, because in the university, in the room, there are 30 people, and the community is connect too.
Is there a way I can see those people somehow?
There are a problem because for the firewall, I need to get out of the room because in the room there are problems with the firewall.
Okay. So they're watching it using the Hangout on Air.
Yeah. In the room, the people is transmitting your Hangout.
Okay. Well, all right. Hello, everybody. Hello, people from Peru. I'm very excited. Thank you for this opportunity. So hopefully, this would be a good presentation. We have about 40 minutes. I believe that is 12:20 your time, 12:23 actually. So we'll go up until 1 o'clock your time, and hopefully you will find this beneficial. I will share some tips about Docker, and if you have any question, feel free to ask them. Well, this is Hangout on Air, so there is no clear way to ask. And if you have any question, Edu, by all means, you feel free to ask me those questions. Okay, so
Okay,
I'm
no problem.
gonna go. And your name is what? Edu, right?
Edu is available only for chat because in the room there are problems with the internet.
Okay, okay, okay. You are Jose or Joseph?
Jose
Jose.
Diaz.
Okay, okay, fantastic. Okay, so let me share my screen then.
Okay.
And at any point of time, if you think that it's going too fast or something is not working, feel free to interrupt me so that I can do the right thing accordingly. Okay, can you see my screen?
Yeah, perfect.
Okay, great, great, awesome. Okay, so let's get started. My name is Arun Gupta. I work for Couchbase. Couchbase is a NoSQL database company. And today we're going to talk about getting started with Docker. Um, I'm a runner, so that's a little bit about that. I like to run. I'm actually running a marathon tomorrow morning, and it's in Sacramento, so I'm looking forward to that. And something else that I believe in is how we should contribute towards educating kids, and bringing them up so that they're ready for the next generation. Because they are the next generation actually. So as part of that, my son and I wrote a book on Minecraft modding with Forge, and I also run the DevOps for Kids initiative in the US. So let's talk about Docker. What is Docker? Well, Docker is an open source project and a company. It really started as what we call as .cloud. It was a small company that was trying to create software containers and quickly became very hot property because everybody realized the importance of it. You can see the number of watches, stars, and forks is pretty huge, actually. There's lots of them over there. Um, Now, Docker is basically used to create software containers. We'll talk about that in a second. But if you think about Java, Java gives you the concept of Vora, write once, run anywhere. Docker gives you the concept of Poda, or package once, deploy anywhere. How does it give you that? Well, think about it. In terms of Java, you have JVM on multiple operating systems, be it Mac, be it Windows, be it Ubuntu, be it CentOS, and a variety of others. Then you have a jar, var, year, whatever your mechanism is, that jar, var, year is understood by the JVM on that specific operating system. Same thing here. In the case of Docker, it very nicely complements JVM or JDK. You have different operating systems. On different operating systems, what you are running is what you call as a Docker engine or a Docker host. And then there is an image, instead of a jar or year, an image consists of your jar or your application server or your database, all of that together. And then the Docker engine understands how to run that image. And the image, when it's run, it's called as a container. So just the way JVM exists on different operating systems, there is a Docker engine that exists on different operating systems, which can be installed and that understands how the image needs to be run. So there are three concepts of Docker, basically, build, ship, and run. Build is what gives you, build is how you define what your Docker image is going to look like. It has, it is defined using a text file. We'll take a look at that, how that text file is defined. But once you put the instructions in the text file, it exactly says that I'm going to be this operating system, this JDK version, this tuning parameter, this configuration, etc. You define a Docker image. Now, once you have built the Docker image, you want to share that Docker image. And that sharing actually comes as part of the Docker distribution. And that's the second component of Docker, which is called as ship. By default, you share these images on hub.docker.com. So that's the public SaaS provided by Docker. And that's where you share your images, and that's where you upload your images and you download your images from there. And last but not the least is the run component of Docker, which is where we say, oh, by the way, I built this image and I shared this image and you downloaded this image. And what do we do with it? Well, that's where we run the image. And that's the run component of Docker effectively. So build is image, ship is registry, and run is container. So think of it as through 3 different components of Docker. One of the typical questions that I see around what is the difference between Docker and virtual machines. So if you're on the left, if you see, and this is very huge props to Docker docs, they're really good. And this is the image right from their docs itself. So on the left, what you see is you could have a laptop, a data center, a cloud, wherever you have, in that you will have a host operating system. So for example, Mac or Windows or CentOS or Fedora or Ubuntu, any of those operating systems. On top of that, you may be running a hypervisor. If it's a type 1 hypervisor, it's a bare metal hypervisor, or if it's a type 2 hypervisor, something like a VirtualBox that runs on top of your host operating system. And then on top of that hypervisor, you run multiple operating systems. So for example, you could have, I'm speaking using a machine which is Mac. So this is a MacBook. So there's a Mac OS X installed here. On this Mac, I have a VirtualBox. Using that VirtualBox, I can install multiple operating systems as virtual machines. There is a CentOS box, there's a Ubuntu box, there is a Fedora box, there's a Windows box, so on and so forth. So all of those can be installed here. And in each of those operating systems, I will have my applications, binaries, libraries, etc. installed over there. So that's sort of how this whole thing works. Now, it's a full-blown operating system in terms of guest operating system. Relies very little on the underlying host operating system for getting anything done. So a couple of points that come across is the operating system, the guest operating system is pretty huge, really big. If you take Windows, for example, it could be like 4 to 8 gigabyte of operating system. And then on top of that, you upload your application, binaries, libraries, etc. So it's really a lot of space it takes up and memory it takes up, etc. And how many can you run in parallel? So that's sort of the limitation of virtual machines. Look on the right side now. You have the same infrastructure, laptop, cloud, data center. On top of that, you're running an operating system. It's not a host operating system. It's any operating system. Just like, in case of JDK, you run it on an operating system, and then you have a JVM on top of that. Just like here, you have operating system, and on top of that, you have a Docker engine. And on top of that Docker engine, what you have is multiple applications that are bundled up as Docker images. And those Docker images are by themselves very self-contained, that the Docker engine understands how to run them. And so there is no concept of guest operating system as such in case of Docker. There is a minimal operating system, very minimal, that is included as part of the image itself. So to give you an idea, on this MacBook, I can run like 3 to 4 virtual machines maybe at a given point of time, but I can run up to 50 to 100 containers very easily. So containers, or Docker containers particularly, give you a lot of density and very high capacity utilization. So let's take a look at it, how my Docker image looks like. I just want to switch back here and check. Jose, so is the speed okay? Instructions okay?
All okay, Arun.
Okay, thank you. So let's see how my basic Docker image looks like. Docker images are defined in a text-based file called as Docker file. And in that Docker file, I have a list of commands that's going to build my image. That list of commands is fixed. So for example, I can say from, here is my base operating system. I can say Fedora : latest. And in this image, I don't want to add or package anything. All I want to do is I just want to echo the hello world command. That's it. Echo is a command that is baked into the minimal operating system. So just these 2 lines are really my Docker file. Now, from and CMD are syntax that are available as part of Docker file. So that every first word, so to say, in the Docker file is a command from is a Docker file syntax command. Let's take a little bit more elaborate Docker file now. So here I'm saying from jboss/wildfly, So there is, Red Hat has published a Docker image for Wildfly. So I'm saying I don't care what operating system is using, but I want to use a Wildfly image. And we'll talk about how this Wildfly image is created in a second, actually in the next slide. But for now, all I want to do is I have a jboss/wildfly image. And in that Wildfly image, I'm just running a curl command. And in that curl command, all I'm doing is I'm downloading the file, which is movieplex7 1.0 snapshot.war. And I am deploying this to really my OPT JBoss Wildfly standalone deployments directory. So what happens is, if I build this image, when I run this image, it's going to start up my Wildfly container by default, because that's what the from jboss/wildfly is doing. And standalone deployments is a standard directory which Wildfly looks for any deployments. So if you drop a war file over there, the file is automatically deployed. So instead of giving somebody, a run.sh script that, okay, run this script and this deploy, this will download Wildfly, start Wildfly, set up the ports, etc. All of that is pre-configured for you in this from jboss/wildfly. And you're saying is, hey, just deploy the war file as well as part of it. So just one Docker file, as opposed to giving it a run script. It's just one standard command. Here's a list of Docker file syntaxes. So you can see there is from, I was talking about, there is CMD, which is a single entry point to the Docker file. Then there is some of the other things I want to talk about is env. So how you can set up environment variables. You can add the files from your local file system to the Docker image, because remember, it's running as a separate container, separate operating system. So you have to copy files from your local machine to Docker container in that sense. So lots of useful commands. But typically, you may think this is a less number of commands, but you can really make very powerful usage of these commands. So how does the Docker workflow really work? Now, three components we talked about. There is three components that are important over here. First of all, in the middle, if you look at it, there is something called as a Docker host, which is where the Docker daemon is running. Okay. Now, in that Docker daemon, that's typically running on a machine, and there is nothing available there to begin with. Nothing as in no containers, no images. Okay. All the containers, all the images, as a matter of fact, they live on a registry. By default, this is Docker Hub or hub.docker.com. Okay, that's a SaaS provided by Docker. Now, a bunch of images, anybody can create an image and upload it on the Docker registry, and anybody can download image from there. So, and then on the left side, what you see is a Docker client. So, typical scenario is you could have one Docker host, which is set up on a network server somewhere, and then there is multiple Docker clients, which are potentially multiple developers, who want to download and run an image on the Docker host. So that's sort of the setup that would be common. Or during development, you might have client and Docker host co-located with each other. That's a very common scenario, and we'll talk about that. That's what I do all the time. Now, the important part to understand is all the images and containers are downloaded and run on Docker host. And who instructs it? That is Docker client. So Docker client is nothing but a binary. And the way it understands which Docker host to talk to is using environment variables. So all it says is, here is the environment variable, Docker_host environment variable, using which it points to the particular host where the Docker daemon is running. And then accordingly, it downloads the images first of all, and runs the containers over there after that. The commands are very simple on the Docker client, as you can see. I want to build an image, so it goes and builds the image on the host. I want to pull an image, so it downloads an image. And it does not download or build anything on the client. The client gives a command, and those are issued on the server, and the server executes them on behalf of the client. So that's how it runs. Similarly, Docker run as well runs it on the host. The client only gives the command, and it runs it on the host. So hopefully that flow is more clear now. Now, we talked about JBoss/Wildfly image. How is that image really constructed? Well, the idea is there is a base image that needs to exist, which is because everything, as I said, requires a minimal operating system. In this case, the base image is CentOS 7. Now, on top of CentOS 7, Red Hat built another multi-purpose image called as JBoss/base because it requires certain packages over there. So it apt-get or yum install those packages as part of that image. So think about it. There is a CentOS 7 image. Somebody builds a JBoss base image, and in that they will say from CentOS:7, and then they will say run apt-get or yum install those packages. Now, JBoss base image is good, but if you want to, does everybody need to install their own JDK? That's where they built another base JDK image. And you can see with base JDK, is looking at base JDK:8. So that :8 basically defines tags, or what people call as versions. So I could have JDK 7, JDK 8, and multiple versions be defined that way. And in the base JDK image, basically JDK 8 is automatically installed for you. And then finally, built upon that base JDK 8 is a JBoss/Wildfly image, which is pulling the right bits of Wildfly, unzipping it, and firing up the server. Okay, so that's how the entire JBoss or the Docker images are built. You always want to define a multi-purpose image on top of which you define more specific images and do the thing that you need to do for your particular application or software. Now, Docker is a Linux technology. It's basically using Linux containers. So how does it work on Windows or on Mac in that sense? So that's where Docker Machine comes in. So Docker Machine allows you to create a Docker host on computer or cloud provider. It works on Linux as well, but on Linux, Docker is supported natively. So there is no need for using a Docker Machine. You can just say apt-get or Docker or yum install, and that will give you the right packages for Docker. But Docker Machine is a CLI, but effectively what you can do is Docker Machine create. You can say -- driver and specify. The way Docker Machine works is it requires a virtualization provider. It's easiest to do if you want to do it on a local laptop to use VirtualBox as that virtualization provider. In addition, there are lots of other providers that we'll talk about in a second. But effectively in this command, what you're saying is Docker Machine create. I'm giving VirtualBox as a driver, and I give it the virtual machine name. And that, so it creates a virtual machine. It's basically a VirtualBox virtual machine in this case. And it gives you certain environment variables. Now, those environment variables can then be used for the client to connect to host. And then the client can say, create images or pull images or start, stop, and restart containers or upgrade Docker, because Docker does a very good job of releasing doing frequent releases. So once you have done a release, you want to upgrade it. So how do you do that? Well, that's a command for Docker Machine. Docker Machine is really not recommended for production yet. So that's an important part to understand. I am gonna switch here and see if there are any questions.
Okay. One moment.
I can't hear you. I'm sorry, I can't hear you.
Okay. This is the moment of the questions. Edu?
Yeah. Any questions?
Edu, any questions? Of the public? Edu is collecting the question or the
Okay.
attendance.
Okay.
No, at this moment. Okay.
Okay.
And
No worries.
very
Okay.
okay.
Okay. We'll start the talk again then. All right. All right. So that's that. So we talked about Docker machine. That's the easiest way to get started with, on your Windows or MacBook. We talked about the virtualization provider. So Docker machine can not only be used for creating Docker machines on your local host, but it can be used to create machines on different cloud environments as well. So, for example, you can do that for Google Compute Engine or EC2 or Azure or DigitalOcean, any of the cloud providers. These are the common ones actually. So I think that's an important part to understand. I'm going to skip the boot to Docker part, but boot to Docker is relevant for people who started with Docker early on. But now it's important to understand that boot to Docker is only an implementation detail. That's how Docker machine really creates the virtual machines. Now, the easiest way to start with Docker is using Docker Toolbox. And Docker Toolbox was introduced in Docker 1.8.0. And now, if you want to download all the tools that you need for Docker, let's say you've never played with Docker and you want to start with Docker, then the easiest way is to download the Docker Toolbox. It has the client, it has the machine. Both of those are important components, because those are the binaries instead of downloading it by yourself. And then in addition, it has VirtualBox and boot to Docker as well. And it has Compose, which we'll talk about in a second. And it has a graphical installer as well. So all the tools are kind of composed together for you into this toolbox, and it's easy for you to get started with. So let me show some examples here, okay? So I'm going to go here. So here I am. You can see the Docker machine command. If I say Docker machine -- help, it says the exact version number. It says create and manage machines running Docker. It shows me all the options.
Pero
Is there
sí,
a question?
levántalo como administrador porque parece que no te deja escribir.
Oh, is there a question?
Sorry.
Okay. So you can see the options. You can see the different commands that are available. So what I can do is I can say Docker machine create. Let me move this up actually. I can say Docker machine create, and I can say -d. I can say VirtualBox, and I need to spell it correctly. And then I can say Perujak. Okay, if I do this, so this is going to create a Docker machine on my local environment by default. Now I have not asked it to specify. So let me open up a different shell. Let this go on. So all I'm going to say is Docker machine create -- help. Now, the moment I say create -- help, you can see there are a lot more other options that are available as well. So we'll talk about Swarm a little bit later, but it talks about how different engine options, how do you want this Docker to be created. I can similarly see -d, Docker machine create -- driver. I say -- driver, nope, that's not giving me any help. And if I say create -- help, no. But I was trying to show that what different drivers are available. I don't recall how I used to do that. But if I get out of this window, go back here. So now I'm in a different shell window that we used earlier. So here I have Docker machine Perujak already created for me. And at the end, it gives me this command, Docker machine env Perujak. So now if I type it, it shows me different commands. Okay, if I want to connect to this Docker machine, I can once again copy this command over here and paste it. And now if I do env on Docker, all the environment variables that are specified over here are now in my environment. Okay, now if I say Docker images, it says no images are available. Or if I say Docker PS, it says no containers are running. Okay, so now I can say Docker run, for example. That's a command to run. Now in this case, I have Docker client and machine on the same host. That's okay for development, but not for production for sure. Okay, so what I'm saying here is I want to run Docker. I want to run the Docker. I want to run a Docker image as a container. The name is jboss/wildfly. By default, Docker runs in the foreground and it does not assign a TTY. I'm going to make it interactive and assign a TTY to it. Okay. I know JBoss Wildfly runs on port 8080, and I want to forward that port on my host from the container. Okay, so that's the command if I use. Now if I do this, it says, oh, I cannot find the image, so it's going to download that image. And remember we talked about how it's built as multiple layers, and so you can see those multiple layers being downloaded now. So it's downloading all those images one by one. And once all of those images are downloaded for you, then it will be able to run it. And you can see the biggest image that is over here is 135.7. That's probably the Wildfly here. And in between, it's downloading other images as well. Those are probably the OpenJDK or the CentOS images, or some of the base layer of CentOS images. Okay, but the idea is once this download is complete, then it will be able to run. The biggest benefit to you is you don't need to download JDK, you don't need to download Wildfly, you don't need to configure it anyhow. It's all automatically done for you. It's all done for you just by giving that single command. And that's the biggest and the best part of Docker, how it encapsulates all those details for you. And you just need to just remember that one command, which will get it going for you. Okay, so almost done now. So give it a few more seconds, and there you go. So now, without downloading anything else, of course I downloaded Docker and all those things, but now my Wildfly is running. Okay, so if I go back here, or let's say if I open up a different shell here, I can say Docker machine. I can say what is the IP address assigned to Peru jug. It says that's the IP address, and we did the port forwarding here. So I'm going to open up a browser here, and I'm going to say :8080, and there you go. My Wildfly is up and running without any significant effort here. So it's very simple in that sense, how you can do it very easily. So if I get out of here, and I can close it. Now I go back to my browser, and I refresh this page. It's going to give me a 404 because, of course, my Wildfly container is shut down. So that's very easy, very convenient. It also gives you that very isolated environment because whatever is happening in the container. If the container goes away, you don't lose your operating system or any of the configurations that way. Okay. By the way, one more thing I want to show here is now if I go back here and I say Docker images, you'll see that jboss/wildfly image was uploaded. One of the typical questions is why it says created 2 weeks ago, because this image was probably created 2 weeks ago. And you can see the total image size is about 584 megabytes. And the important part to realize here is you can see it has operating system, JDK, Wildfly, everything packaged in it. So it's about 0.5 gigabyte. It's not bad actually at all. So it does give you a good understanding of how the whole thing works basically. Okay, let's go back here. Now, if I were to run one service, I showed you some commands options. -p for port forwarding, -it to run it in an interactive mode. But if I were to run Couchbase, which requires typically a few port forwards and a volume mapping, because I don't want to store my data of a database container into the volume and into the container itself, because if the container goes away, I'm going to dump it. I'm going to start a new container. How do I grab that data and map it into my local host? So that's where I'm doing volume mapping. Now, if I were to give a lot of commands, do I put them in a shell script? Well, that's where Docker Compose comes in. So it says Docker Compose is a tool that allows you to run one or more containers together very easily. A simple example is I want to run a Docker container, a Couchbase container, and just one command, and you say Docker Compose up, and it'll use this file definition, which is basically a YAML file definition, and it'll fire up the container. Now, if I were to run this on a command line, I will have to create this complex command. And let's say I want to run Wildfly as well, where I want to run a Java EE application, which is doing a CRUD over a simple Couchbase bucket. The way in relational databases you have tables, in NoSQL you have buckets. So from the bucket, if you want to grab the data and do some CRUD operations on it, then you want to do a Docker run, and you want to Docker run on Couchbase and Docker run on Wildfly, and you want to connect the two together, because essentially they talk to each other using database connection. The Java EE application in Wildfly needs to know the IP address of the host of Couchbase, and the way you do that is using linking. That's called as a container linking. Now, container linking is a concept that was introduced in Docker early on, but the disadvantage of that is it is confined to a single host. It does not work across multiple hosts. Docker introduces the concept of multi-host networking. We may not get time to talk about that today because we have about 5 more minutes, but that allows you to run Wildfly and Couchbase on separate hosts, where you can easily do a multi-host, multi-container applications very easily. But essentially, you will have your Wildfly in the middle, which is where your Java EE application is deployed. That is CRUDing your Couchbase data bucket. And the way you will do that is using curl application. So what I want to do is I'm going to switch here, and I want to take you to my blog, where I just blogged about it recently. There you go. So this is the same image I was showing you earlier. All the instructions for this sample application that I showed are available on Couchbase-Java EE on my GitHub repo. And in here, you can see how you can start up an application. Well, first of all, what we're doing is we are creating a virtual machine. And in this case, I'm saying I want the virtual. By default, the virtual machine is 1 GB in space. But because of Wildfly and Couchbase and everything else, we have to create a little bit bigger image. So I'm saying create a 5 GB image instead. Then I'm connecting to the Docker machine. Then I have a Docker Compose file here. So if I look at my Docker Compose file, which is over here. So let's take a look at the Docker Compose file in this case. So there is my Couchbase. Here I'm saying, here is my Couchbase definition. Here is my Wildfly definition, and they're connected to each other using this Couchbase URI. Okay. Now, if I fire up the container, I'm just saying use networking as this is an experimental feature introduced in Docker 1.9. But essentially, all these images are downloaded and pulled, and then it runs. Finally, I configured the Couchbase server, so I can just give this command Docker machine IP Couchbase-Java EE. Now remember, if I provision a Couchbase server using Docker container, I need to make sure, just like in an RDBMS, you need to create your database schema, etc. here we need to configure the database, not the schema, but the bucket, and upload it and set the size, etc. So that there's a Maven profile in this application over here. So you're just using simple REST API to configure your database. And finally, you deploy the application to Wildfly. I'm saying, okay, this is where my Wildfly container is running. So get the IP address. I'm just using Wildfly Maven plugin to deploy the application. And here is the admin username and password. Now, if I go back here, look at my POM XML here. This is my Wildfly plugin. And here you can see, if I say Maven install, it's going to use the deploy of the Wildfly plugin. Okay, so that's good to know. I think given the amount of time that we have, I'm going to skip through some of the details here, and I'm going to jump here. So that was sort of a quick introduction to Docker Compose. Now, we talked about Docker machine. That's a single host. How do I create a Docker cluster that spans multiple hosts? Well, that's where Docker Swarm comes in. Docker Swarm gives you a native clustering for Docker. You can create multiple hosts, like they could be Unix-based, like on any cloud, or they could be Docker machines running on your local laptop. But in front of that, it gives you a unified interface where you can use the Docker client to talk to the Docker Swarm. Now that Docker Swarm, of course, is a cluster of Docker hosts, but the idea is the Docker Swarm itself serves the same standard API as a single Docker host. So all your tools scale very well. Today, they may be talking to a single Docker host, but by changing the environment variables, you can point it to a different Docker Swarm, and now it's talking to multiple hosts. It's fully integrated with machine and Compose. So you can say, I want to create multiple machines, and each of those machines are essentially going to be part of Compose or Swarm cluster. It's 1.0.0 ready for production, but typically, as developers, we're a little bit cynical. We don't take 1.0.0 for production, so there will be bug fixes, etc. But Docker, they have stress tested Docker Swarm on 1,000 Amazon nodes, and they've been able to run up to 30,000 containers on it. So that's pretty compelling, stress test that they have done. Okay. So how does a Docker Swarm cluster look like in that sense? Well, Docker Swarm cluster, in that sense, think of this. There are multiple Docker machines running at the bottom. Those Docker machines, they join a Docker Swarm cluster. Then your Docker CLI on the top, it gives a command to the Docker Swarm cluster to download or pull an image. And again, once again, as I said earlier, it is purely using environment variables. At one point you were talking to a single host, you just change the environment variables. Now it's talking to a bunch of different hosts or Docker Swarm cluster. So just by changing the environment variables, you can point to the right set of machines. And the Docker, the way these machines understand that they're part of the cluster, they need to talk to a discovery service. That discovery service is just nothing but a key value pair. Could be done using console, Zookeeper, etcd, or a Docker Hub token service, and there are several ways to do that. My blog actually has well, let's talk about this here in a second. So if I go back here, back on my blog, so here's a blog which talks about the same application that we saw earlier, Wildfly Couchbase Java EE application, how it could run on a Docker Swarm cluster. And all of these nodes are now talking to discovery service, and I have a Docker Compose application that is talking to the Docker Swarm cluster. So that makes it that much more easy. So if you want to understand all the concepts of Docker machine, Docker Compose, and Docker Swarm all together, this is sort of the blog that you're looking at it. And it has complete details, complete source code that you want to understand and how you want to get going. So I would highly encourage you to take a look at it and give comments, what works, what doesn't work. Okay, we are almost out of time actually. So what I want to leave you guys with is, if you go to GitHub this is a Docker Java project that I created early on. It's on Java EE-samples. The best part here is if you look at the Docker, this is basically Docker for Java developers recipes. Okay, so if you click here, it takes you through a very simple, easy to understand, self-paced, hands-on lab. You can follow the instructions that are given over here to create a Docker environment for yourself. And then it teaches you through the basic Docker basics of Docker. How do you build an image? How do you run a container? What the different commands are for that? How do you deploy a Java EE7 application? How do you do the container linking? How do you build and deploy completely, using Eclipse, Docker Maven integration? How do you test applications? How do you do Docker Compose? How do you do Docker Swarm? And then finally, towards the end, it also talks about Kubernetes, as a matter of fact. So this particular lab has a lot of details that you will find useful. So once again, the link is github.com/java-samples-docker/docker.java. Now, the slides that I presented are also available in this slides directory. There's a PDF and there's a keynote. You're welcome to take a look at it and use it any way that you find it appropriate. So there's a lot of Docker content available on this one directory. So by all means, I would love, if you want to give any feedback. So what I'm going to do now is close this tab, go back here, and stop my screen and see if there are any questions. Was that?
Thank you. Thank you very much, Arun.
Yeah, you're always welcome. Are there any questions from the audience?
Okay. One moment, please. 1 minute. Edu, there are any question of the attendance? Edu? Any question, Edu?
I see Edu is typing something.
Edu? Okay. Edu is... there are one question, Arun. Are there support between Docker and VMware?
Yes. So let's take a look at that. So if I go back here, so one of the slides that I explained earlier is, you can create Docker machine, and when you create Docker machine, that can be used to create your Docker machine on using different virtualization providers. Now, these are only some of the virtualization providers for you here. So what I do is I say Docker machine, and I say VMware. Okay. If I Google on this, here you go. It brings you back here. As a matter of fact, if you look at Docker docs, it talks about how VMware is directly supported. Now, remember when we said here, for example, Docker machine create -d VMware. Let's see, I think the name is VMware Fusion. So if you look here, the complete list of drivers are listed here. And in terms of VMware, there is VMware Fusion, VMware vCloud Air, and VMware vSphere. So if I look back at Docker machine reference here, let's see what does it say here. Docker machine create -d VMware. VMware Fusion. Oh, there you go. Okay. So if I say VMware Fusion, then it's giving me more properties that are available for VMware. So yes, there is a direct relationship. There is a direct integration of VMware with Docker. You can create your Docker machines on using VMware virtualization provider. That is one. Or let's say you have VMware virtual machines already, like CentOS or Ubuntu. Then in that case, on that CentOS, you can say yum install Docker machine or Docker engine, and then run Docker host on that virtual machine. So there are a couple of different ways by which you can do that. Oh, I'm sorry. I think I was sharing my screen, but I'm not. Okay, hold on. Let me share my screen and quickly walk through that again. Go back here. So here, sorry, I was showing here, for example, how it provides full integration with VMware. There are different URLs which specify how you can create a Docker machine on VMware, and then it shows VMware Fusion. And if I go down here, Docker machine reference, you can see the drivers here. There is VMware Fusion, vCloud Air, and vSphere. It provides you full instructions on how do you do integration with them. Any other questions?
Okay, Arun, no more question. Thank you very much for your time and support with our community.
Absolutely.
I'm sorry because I missed to introduce to the attendant. Ladies and gentlemen, Arun is Vice President, Developer Relations at Couchbase, and he's a principal Java champion too. Thank you, Arun. I'm sorry. Last question. How this impact in Java developers in the future?
Right. That's a great question. Thank you, Jose, for the introduction. But this question is very relevant, actually. Now, if you remember, one of the slides I presented very early on is, well, let me share my screen first here. The whole concept of PODA, which is package once, deploy anywhere, very nicely complements the VORA concept that is provided by Java. Now, Java gives you the ability that you have a WAR file and you can deploy it in a Wildfly application server or JBoss. But then you do need to tune it or tweak it or deploy the right JDBC drivers. So instead of giving somebody a deployment scripts, you can say, here is my Docker image, and that Docker image is pre-tuned, all the drivers are installed, and everything works out of the box. So I think it very nicely complements the VODA concept to PODA.
Okay, very nice, Arun. One question?
Yeah.
Additional question? Edu? Edu? One question?
Yeah.
Or nothing more? Cool. Only say cool.
Okay.
Thank you, Arun. Thank you, Arun.
Thank you so much. I really hope to come to visit Peru one day. I've been really planning to be there one day. So hopefully I'll be able to speak to you guys one day in person.
Awesome, Arun. Let us when you decide to visit to Peru. Peru is it has an awesome gastronomy and beautiful places.
Absolutely.
You enjoy this country.
I would love to. Thank you so much. Thank you, Jose,
Thank you,
and everybody. I love the Peru Java community. Bye-bye.
You have many fans.
Bye.
Bye.